Large quantity purchases. You know, just about the time I was coming of age, two guys, Tobin and Baumel, figured out an optimum amount for you to withdraw, purchase. It's a trade-off between the amount and the number of trips and the cost of each trip. Sparing you the calculus derivation, it turns out that the optimum of the total of the two is when the cost of each crosses each other. A little mnemonic memory trick for the optimum is taking the square root of King Tut overseas. 2 times the usage times the transaction divided by the carrying cost, which could be either per unit or per dollar. Let's do an example. We have a big old Great Dane, eats $8 a day, and that's 1/10 of a $80 bag. A trip to the pet store costs $2, either actual or time and effort, and let's say the interest rate is 5%. First of all, what's the current policy? Let's figure the optimum. Compare the two and confirm if our answer is correct. Well, the current policy, we're getting an $80 bag. Half the time we're above and below at 5%. And, let's see, that's, that'd be 36 times a year, $2. That adds to $74. Well, the optimum, remembering King Tut overseas, that's 2 times that $8 a day. Let's say there's some 360 days, $2 for the trip, 5% as a decimal, and we get $480. That would be 6 bags every 60 days, 6 times a year. Looking at the optimal cost, that's $480 on average, dividing by 2, 5%, plus the 6 times a year times the $2. Well, we get 12 plus 12, $24, saving us $50 a year. But notice we confirm the answer because the 12 and the 12 are identical. Let's do another one. Let's say a person gets $20 weekly from an ATM, costs, say, $4, time, effort, and charges, and the interest rate's 5%. Again, the current policy would be half the average of that $20, 5%. That's 50 cents. And then there's 50 trips at $4, that's 200. But now let's compute the optimal. Well, let's see, that's 2 times that 20 times 50 yearly times the $4 transaction divided by 5%. That's $400, or every 20 weeks, or every 2.5 times a year. Let's check the result of our optimum choice of the 400. Well, half on average is then 5%, $10, and 2.5 times a year, another $10. Confirmed because the two terms are equal. Now here's a large example. Say smoking menthol cigarettes, which is no longer available. Got to go to Las Vegas. I know, no scolding. And we do some computations, the mileage, the cost per mile, the gas, the time and effort, and it turns out it's about, say, $260. Well, using our formula, we're going to have 2 times smoking 3 packs a day. I know, $10, far cheaper than anywhere else. 360 days. The cost of that trip is $260. 6% interest rate, taking the square root. We get some almost $10,000. I know, but let's check that. Half of that times the 6%. And we figure the number of trips, which is almost about 1 a year. Yeah, the two terms are equal. And that turned out to be about 3.2 cases. But you know what? The formula is very forgiving. It tolerates a lot of variability. If you were to double the trips or double the quantity, it's only 25% more. So you can be really sloppy in the analysis. Drcinvests.